Now let's move on to orbital velocity. From what we learned about centripetal force, we can derive the equation for orbital velocity. Here's how you do it. Picture Earth and a rock orbiting Earth. The force on the rock exerted by Earth will be equal to the centripetal force, and the centripetal force is equal to the force of gravity exerted by Earth. Since this is the only force felt by the rock, the centripetal force equals to the sum of the centripetal forces equal to the force of gravity. We know that the force of gravity also equals to big G times m1 times m2 over r squared. And we know that the equation for the centripetal force equals m1, which is the mass of the rock, times velocity squared. Here you can't really see the square. Times velocity squared over r. Remember, it's important to know that the mass m1 is equal to the mass of the object in orbit, not the Earth. When you simplify the equation for v, you get v equals to square root of g times m2 over r. m2 is the mass of Earth. What we learn from this is that the mass of the object orbiting the Earth, or any large body in space, doesn't affect the orbital velocity.